Okay, lesson 7.2. 7.2 builds on what we did yesterday in 7.1. So before I start chatting 7.2, I need you to answer some questions. The graph 1 over x from yesterday. Tell me what quadrants you're in. 1 over x. 1 and 3, awesome. What if I did 1 over x squared? Where am I? 1 and 2, awesome. So when I did 1 over x squared, I knew my domain is all real numbers except 0. But what was the range for 1 over x squared? The range, nope, no. On 1 over x squared, so 1 over x, it was the same, but 1 over x squared, remember you just told me you're in quadrants 1 and 2. So from 0 to infinity, do I include 0? No. So y is bigger than 0 or parentheses 0 to infinity. Either way would be absolutely perfect. Either one of those. Okay? Next thought. What if I did y equals negative 1 over x? Where am I? 2 and 4, awesome. Because what was in 3 flips up and what was in 1 flips down, so they flip-flop. The negative power, so you're flipping it around. So today we're going to be taking those graphs from yesterday, and we have one added step. So do you remember back when we did parabolas where we had an A, B, C, and D? It's still on the backboard. So A was your stretch, your vertical stretch and compress. We're not having to deal with B at all in here. C moved it, do you remember? To the right and to the left, and D moved it up and down. So today we're dealing with C, which means we're going to move our graph right and left. That's all we're doing, okay? Now, if I take this denominator, look up here, if I take this x minus c and set it equal to 0, would you agree I get x equals c? That's going to be my vertical asymptote in its new position. So that's what we're going to be dealing with as we move on. Now, this was the original. This is what we did with the other shapes. Now we have the a in the numerator. The a is going to stretch or compress it depending on if it is a 2, 3, 4, 5, or if it was a fraction. We're not going to have to deal with b. C moves it right, left, like I said. And guess what the d does at the end? Up and down, exactly. So today is just C. That's all we have to deal with. So the abbreviated version looks like this. Y equals the A over x minus C. That's what's going to take care of moving it right and left. Question? Anybody? Okay. Now, these are guidelines for graphing rational functions. When I get to the horizontal part, we're doing one of the rules today, and then another rule in a couple days, because it builds. So when you go to make these rational functions, 1 over x squared, 3 over quantity x plus 2, whatever it is that we're graphing, the first thing I'm going to need you to do is give me the vertical asymptote and sketch it in. The horizontal asymptote, sketch it in. Bless you. You're going to build a table. It might be a tiny table where it just has 2 values in it, but a table. And then you're going to make your nice smooth curves, okay? My nice smooth curves are not 90-degree angles, so please make sure they have curves to them. So you're starting off with this function right here, and we're going to take for step 1 the denominator, whatever it is, and you're going to set it equal to 0 to solve for x. Didn't I just say that on the last frame? So that's my step 1. That's how I'm going to get the vertical asymptote. Now, when we get to section 7.4, you're going to have to go a step further and tell me if it's a vertical asymptote or a hole. Hole meaning H-O-L-E, like if you took your pencil and punched a hole through it. You would have that open point there. We have a sample of it coming up in this part of the lesson, but we don't have to actually do anything with it till 7.4. Your horizontal asymptote. I'm going to be working with the degrees. Do you know what a degree is? The powers, the exponents? Okay. N stands for numerator, D for denominator. Today, we're just doing this one. If the degree of the numerator is less than the denominator, we're going to have a horizontal line at y equals 0, the x-axis. So check this out. I wrote up here 3x to the 0 over x to the 1. Would you agree that 0 is less than 1? Okay, so that fits that the degree of the numerator is less than the denominator. You also know that anything to the 0 power is really the number 1. So that's like 3 over x, which we graphed yesterday. So you already know how to graph that. And it's saying, oh, the horizontal asymptote was 0. Was it 0 yesterday when we graphed 1 over x? Yeah, it's still 0. Now, tomorrow or the next day when we get to 7, 4, all of a sudden we might get where we have an x squared in the numerator and the denominator. If the degrees are the same, we're going to have a different rule for the horizontal asymptote. So this is what we're going to build on when we get to 7, 4. You'll already know this one, so then it'll just be learning this. The third one says if the degree of the numerator ends up being bigger than the denominator, you have an x to the 7 in the numerator, x to the 3 in the denominator. 7's bigger than 3. There is no horizontal asymptote. You don't put one in. In pre-calc, you'll take those values, the polynomials that you get, and you'll be making diagonal asymptotes. But we don't have to graph diagonal asymptotes in here. So you just put there's no horizontal because there aren't. And then you learn more about that equation in the next course. Okay? Then, of course, you make your table so that you can make your nice smooth curves. So does anybody need to write anything down or take a picture or whatever? And then the rest is, let's just do lots of examples. As they're writing stuff down, quick reminder again, make sure the survey's in. So today during lunch, if you haven't done it yet, make sure you get it in so you don't forget. And then make sure if you have intentions of doing a retake tomorrow that you make plans so that you can do that. There will be 2 other opportunities coming up. I don't have those dates yet. Study guide answers are already posted online. So if you need those, I have at the end of the lesson which problems you can already do from the study guide. You know, extra copies of the study guide are online as well. Anybody still using this frame? Lovely. Okay. So here we go, textbook page 555. They give us some really good examples here that we're going to work. So if you could kindly turn to that page, it would be helpful. Now, we start off with a basic 10 over x. We did that already, one like it yesterday. I think we had a 5 over x and a 9 over x, so 10 over x is a relative. Then we're going to start doing some shifts. We're going to have, given an equation, I'm going to name the domain, range, vertical, and horizontal asymptote. Then, given either a graph or a table or a description, you're going to derive the equation that comes with the problem. Okay, with the little pieces we already know, and you already know a lot. So step 1, if you had to explain, you're tutoring somebody, you're tutoring me, and you need to tell me to make a sketch on my paper and where for 10 over x I should put my 2 branches. Could you tell me where to put my branches in what quadrant? 1 and 3, awesome. Okay, so there's 1 and 3. Questions so far? Okay, next. We want to name the domain. This is still the parent, even though we have a 10 up on top, it just stretched it a little. So what was your domain? What can you plug in for x? You know this. Anything but? Good. Now, my asymptotes were right here and right here because we haven't done anything yet. What is your range? Good, anything except 0, perfect. When you name your VA and HA, don't forget the variable that goes with it. So the vertical asymptote is perfect, x equals 0. And the horizontal one is perfect. Okay, questions so far? Okay, so that was what we did yesterday. Now, I am taking my parent graph, 1 over x, and that plus 10 on the bottom is telling me how to move my vertical asymptote. If I take quantity x plus 10, set it equal to 0, and solve for x, what do I get? You just gave me my new vertical asymptote. Now I have a vertical asymptote at x is negative 10. With me so far? Okay, take the denominator, x plus 10. If you set it equal to 0 and you solve for x, do you agree? Okay, so that says that now that is your new vertical asymptote. So let's sketch that in. So instead of having a VA at 0, now we have to put 1 over here at negative 10. So let's change color. So we have a VA happening right there. Now, I'm going to make my sketch. My whole sketch, my 1 over x sketch, when I move the asymptote, gets moved with it. So I'm moving everything over to the left 10. Are you with me? So that means I have a nice smooth curve like that. See how the whole curve moved over with it? It's like it drags it. And then I have my other one. Wasn't it in quadrant 3? So then we'll have this guy right here. So all I did was I took what you knew right here to be the VA on the y-axis, and it said, no, your new asymptote is at negative 10. So I made a dotted line at negative 10. And then the graph goes with it. When you, just like on a parabola, when you pick up the vertex and move it, the whole graph goes with it. When you move the asymptote, the branches go with it. Okay, now, with that being said, the domain is not all real numbers except 0. The domain is all real numbers except, bingo, bingo. How come? It would equal 0. Look at the equation. You even know that piece from the equation from algebra. If you put a negative 10 in there for x, isn't negative 10 plus 10 0? Can you divide by 0? No. Okay, next. The range. Has the range changed at all? No. So it's still all real numbers except 0. We already have the vertical asymptote. Has my horizontal asymptote changed at all? Did I go up or down any yet? Anybody? No. So it stays the same at y is 0. Because we're doing little steps. Today we're just moving it right and left. Question? Uh-huh. Yeah, were you not here? Or okay, so the vertical or horizontal asymptote is the line that you're approaching, but you don't touch. So when it's vertical, it's x equals a number. Horizontal is y equals a number. And you get the vertical one by taking your denominator, set it equal to 0, solve for x. Better? Okay. Huh? Anybody else before I move on? Okay, next thought. Now I have a picture. Given a picture, I should be able to write the equation. Now we won't learn about a until we get to the table. So you're still thinking that y equals a over x minus c. Your a until I tell you is 1, okay? Because you don't have enough information, enough detailed points to do anything else. So look at this graph. Would you agree the asymptote moved? Where is it at? Good. So could you derive an equation then if we know we have a VA at x is negative 4? What do you think? 1 over, perfect, 1 over x plus 4. Because we translated it 4 units to the left. Question? So given a picture, you should be able to tell me an equation that goes with it. Anybody? Okay. Next is a verbal description. Vertical asymptote is over at x is 3. still have a horizontal asymptote at y equals 0. 1 over minus 3. Good, because this went 3 units the other way. 1 over x minus 3. All these would be great ways of me asking you the same type of question on an assessment. Okay, next one, I give you the domain and range. Still, there's just enough to be able to write the equation. So it says your domain is all real numbers. Look up here, or you're looking at your paper, either one, but not into space, please. All real numbers except x is 7. So what is my denominator? Good. Do you see the repetition? Okay, now I'm going to add to it since you said yes. Now, here's a chart. I have 2 of these with the table. The part that says undefined would say that like on a graphing calculator, or it might say the word error on a graphing calculator table. That is where your vertical asymptote is. That's where you cannot touch. So this is saying that if I plug 2 into this equation, whatever it is, my calculator is going to say error, which tells me it's my VA. So this 2 right here is this right here, x minus 2. Now, would you agree I have a whole bunch of xy values on my chart? Look up here. So I can choose any ordered pair I want and drag it into my equation, replace x and y, and I can find a. So look up here. I took 0, what a surprise, 0, negative 1. So I replace the x with 0, and I replace the y with negative 1. Good there. Do you remember cross multiplication? So if I multiply negative 1 times the answer to 0 minus 2, would you agree you get 2? So a is 2. So now I get this nice answer, 2 over quantity x minus 2. I'm going to do a second one as well. Okay, watch this. Undefined, so denominator has an x plus 1. Are you there? Take any ordered pair. I took 0, 3 into the equation y equals a over x. And what did we say to put on the bottom? Plus 1. I want to replace both the x and the y. So if I use the ordered pair 0, 3, where there's an x, put a 0. Where there's a y, put a 3. 0 and 1 is 1. Cross multiply, a is 3. So now up top here, instead of a, put 3. Huh? On the bottom? Right here, see where it says negative 1 undefined? So that means that's where the vertical asymptote is. So if the vertical asymptote is at x equals negative 1, then what's your equation on the denominator? X plus 1. So you had to do that first. So I first found this x plus 1 down below. Then I took any ordered pair I wanted here, whichever one you want. It doesn't matter. You could go eeny, meeny, miny, mo. I chose 0, 3. Replace the x and the y value so that you can find the missing value a. And then you put it back together. You'd have to simplify it more. I chose something easy so that when I simplified it, I didn't have to do any work. Pardon me? Well, with this group, yes. Yeah. Anybody else? Okay. Next thought. So what I need you to do is I need right quick my group of, so I've got CD and CD that I am assigning. So this C and D have x squareds on the bottom with extra stuff to move right, left. And then CD down here have cubes on the bottom. So I want these two groups right here to do the first C. So you guys right here. So start. I want this group of 5 of you to do the first D. I want this group right here and this group right here to do this C, okay? I want the back group to do this D, okay? And then designate somebody to share out. So I'll scoot it a tad bit more so you can see. So you'd have to be able to make a sketch, which means you know your VA and HA.
Wait, at 0 would it be negative? It'd be negative 1.
You're trying to make a graph, make a sketch, and then label your VA and HA.
Yeah, all real numbers except.
As soon as your group knows how to make the graph, if you can come on down, I can have you make the sketch and I'll do the chatting. Anybody from Group C, the first part? Anybody have it done? Group C, Group C. Did you talk to your group right with you, right behind you? Them, yeah, that whole group is 6. You all have C. Oh, you do? Oh, it was this group right up here then? You guys are all have C then.
Hey guys, I think I can. Wait, are we looking at Actually, yeah, that would be true. All numbers except 0.
Okay, let's pull it back together. So, Group C, there's 6 of you. I need a volunteer to come up here and make the sketch. First Group C, there's 6 of you. Who's coming? Okay. First Group D. So you can put it right in here. And just don't put your hand onto here because then yeah. Group D, there's 5 of you right here who's coming up. Group D. Okay, come on up. Second Group C, who's coming up? Second Group C. I'm doing the talking, so all you have to do is draw. And Group D in the back. Group D, second Group D in the back. Okay, so just line up. Awesome. Okay. Which one are you? Okay, you can draw.
Yeah, it flips it to the other one.
So if they're both on two, one's on the top, one's on the bottom.
Good. Pass the pen.
He's just asking.
Okay, Group D in the back. Let's go. You're the only group that's not up here, and there's more of you than any. You guys are telling me there was 9, 10 of you back there. You should have been able to figure that out.
It's not what I thought, but it might be.
It's the same as the one X over X.
You're making it worse. No, you're supposed to asymptote up higher.
Because I had it saved on something else, but when she picked it up and then put it back down, it went back to the color of the pen that's actually in her hand. Okay, guys, so let's take a look and see what's going on. Shh. So the first one, your VA up here, the VA was at x equals 2, so do you see it there at 2? The horizontal asymptote that you would want to dot in on your test is still at y equals 0 on everything today. And they are both up on top because it was a positive. So they're both nice, clean graphs like in quadrant 1 and 2, but shifted 2 units to the right. Graph D, instead of being quadrant 1 and 2, will be in quadrant 3 and 4 because you reflected it over the axis, over the x-axis. And then, same thing, we moved it 2 units to the right. On C and D down here, now we have third degree, cube. The cube, the 5, the 7, the 9, they're all related. So you start off with quadrant 1 and 3, but we needed to shift it 3 units to the left for the vertical asymptote on both of them. So we were in quadrant 1, we just moved it 3 units to the left because of the x plus 3 down below. And then this moved with it, so as you move your asymptote, all the branches go with it. This one had a VA at x is -3 when I fixed it. And the reflection of 1 over x would be the -1 over x. So what was in 1 went to 3. What was in 1 went down to 4. What was in your 3 went up to 2. And then we moved it all 3 units to the left. Okay, so make sure, given any of these problems, that you could do it independently, not with a group of partners of 3, 4, 5, whatever it takes. Okay, next thought. Look at this denominator right here. It says x squared plus 4. So they want me to talk here. It says, without graphing, I need to figure out the number of vertical asymptotes. So this one says there aren't any, none. There's none for multiple reasons, but step 1, take this denominator, set it equal to 0. Set this equal to 0. What would you get if you move the 4 to the other side? X squared equals -4. Can x squared equal a negative in the set of reals? No. So that's why there's no vertical asymptote. When you get something like that, x squared plus a number, that means there's not going to be a vertical asymptote. It can't happen because you're not going to have any imaginaries in your answer. Okay? Next one. I know you can factor this. X squared minus 4. Please factor. Tell me what you would get. X, good. X plus 2x minus 2, which means you would have vertical asymptotes at x equals 2 and x equals -2. Awesome. Can you factor this perfect square trinomial? We did it in Algebra 1. X squared plus 4x plus 4. So you go x and x, plus and plus, 2 and 2, which is the same thing as saying x plus 2 squared. So where is your vertical asymptote at? X equals -2. And it would be the same VA twice. You don't have to go over it a second time. I'm never going to know the difference, but that's what it is. It's like one on top of the other. Now, these are all different examples. So what I'm going to have you do is share out the answer to me, and I will actually write it in. So I'm going to give you a letter from the alphabet up here, and you will respond with the vertical asymptote that goes with the problem. A, B, C, D, E, F. I'll come back in a sec. G, and then the group of 6 girls, H. Okay? So look at A and B real quick because I'm going to scoot it so that they can see the last two. So somebody write down A, somebody write down B.
How do we factor this? So that we have.
Do you have it written down, A? Do you guys have B written down?
Yeah.
Okay.
Definitely have.
The G and H group, your problem's up there as well now? They're a tad bit different, but once you see it, it'll be easy.
No.
Actually, yeah, it would be after. It's 5. So then what do we do with the 5?
Nope, all you're going to do is give me the VA. Or the VAs, if there's more than one.
Well, would X equal 1 because there's 5 on top?
No. We're trying to find the in the bottom first.
Did you guys write down G? Okay, over there, did the group of 7, anybody write down H? Did you guys write down H? In the back, did you guys write down H?
Yes.
Okay. So some might have multiple answers, some you have to factor to get your multiple answers. A, you guys are done? B, are you done? It's already factored for you. C, are you guys done? D, E, F, G, H. Yes, no, sort of. Okay. Okay, here we go. A, speak out. Okay, so I heard the value 5, but it can't just be, if I'm naming a vertical asymptote, it always has a variable with it. X equals 5. Now, couldn't you just take the denominator, what was my rule, set it equal to 0, and solve for x? That's it. So we get x equals 5. So if you have multiple values, then group B, what are you going to do? Okay, x equals 2, x equals 3 over 2. And in each class, except for one so far, people forgot one other, which was the x equals what? 0, exactly, like we did the other day, yesterday. So if you take x and set it equal to 0, you get 0. If you set x minus 2 equal to 0, you get x is 2. And if you set 2x plus 3 equal to 0, take away 3, divide by 2, you get negative 3 over 2. Good job. Question?
So A does not affect.
Does not affect the vertical asymptote. Kind of like A also didn't affect the vertex when we graph parabolas. Okay, C. Perfect. So step 1, this took you back to your basic factoring, x minus 5x plus 2. Then you had to set each quantity equal to 0 and solve for x. Good job. Oh no, next one had factoring with a leading coefficient. Yes? So we have negative 1/2 and negative 4. Perfect. So to factor this one out, 2x in one, x in the other, signs are the same, they're both plus. 4 can be 4 and a 1, 1 and a 4, 2 times 2. You play with it until you can get it to work. And then we had 2x plus 1, x plus 4 that worked. That's your algebra 1 part. Set it equal to 0. Solve for x. We get negative half and negative 4. Good job. Okay, next one. X equals just 1. So I got 1 and negative 1. So this is me thinking back in lesson 4.4, we had to factor stuff like this. So I broke x to the 4 minus 1 up to be x squared plus 1, x squared minus 1. X squared plus 1, you know, is going to give you imaginary. So I'm done with that. I don't need that. That's not going to help. But x squared minus 1 is difference of squares. You can either factor at x plus 1, x minus 1, or you can set x squared minus 1 equal to 0. Add 1 to the other side. When you square root, don't forget your plus minus, which gives you both a positive and negative 1. Question. And if you factored it, wouldn't you get that x plus 1, x minus 1? Okay, next one. There was no vertical asymptote because you would get imaginaries. Good job. Okay, these two are a tad bit different, so I need 100% focus, please. Thank you. Okay, so that is one of the common mistakes, x equals 2. So there is something happening when x equals 2. It's just not a vertical asymptote, and I haven't taught it to you yet. If you step 1, so think algebra 1, do you see x minus 2 over x minus 2? Do they cancel? How many times does it go into itself? So this is really a line at y equals 1. Are you still with me? Now, this line at y equals 1 is going to have an interruption in it, but it's not going to be a whole asymptote. It's just going to be a whole. So when we get to section 4, you're going to have to sketch something that would look like this. So we're going to draw a line at y equals 1. There's a line at y equals 1. But when we get to the value x is 2, it's going to have a hole. That's it. An open point. Yeah. It's saying don't include me there, but it doesn't need a whole asymptote. It just gets 1 point of interruption. So that's coming attractions. It just happens to be here, so you can think about it. Now, this one has a VA, but it also has a hole. What did you guys get?
X equals 5.
At negative 2, exactly. So x equals 5 is going to be your vertical asymptote. And then the coming attractions, you already know, you're going to have a hole at negative 2. Okay? So please, please work these through. Now look at my detailed directions for the assignment. You are doing, on the skills practice, 20 to 30 all. When you do 20 to 24, I want everything. I want VA, HA. When you're sketching, I want to see the little table in the graph. I also want you to tell me the domain and range. So everything you can tell me I need. And then I wrote which problems from the study guide you could already do so you don't procrastinate till the last minute. Okay? Remember, surveys due by class period tomorrow when you come in, and extra help tomorrow after school, and first retake opportunity tomorrow after school.